a microphone now and I can hear it. And earlier, I think I was using a microphone that wasn't working. Okay, yep, there it goes again. So you know what, I'll try it for a bit, but if it keeps cutting out, I'm gonna put it down. Okay, so how'd you think of the first 3 sections? That was good? Good stuff? Okay, now you gotta put your finger in your left ear and push to make space for more information now. So we're gonna shift gears a little bit now, and we're gonna use some of the stuff you just learned about as a background for this, but we're mostly talking about now the TV evolution to all IP. Whereas there were hot topics before, this is just as much a hot topic, but it's much more involved. And why we're moving to all IP is to in order to implement all these new things like Ultra HD, 4K, HDR, all this stuff, you want to be able to do it now. So, 2 parts in this, another 90 minutes here. We got about half and half. We have professional media over IP, where we'll talk about the new SMPTE standards and AMWA, Advanced Media Workflow Association, open specifications. And then while we're making this transition to all IP, we're going to talk about the movement to everything virtualizing in the software and why they're beyond networking, we're going to have software-defined media processing and where that's leading and how, the new change is really about going to the cloud, and virtualization in and of itself doesn't provide that. It's really about converting to microservices and containers. So it's not the same virtualization that you had before. So with that in mind, we're going to start with professional media over IP. So let's see, it's been about 30 years now since we converted from analog to digital. It was done for efficiency reasons, to get more things accomplished in a smaller space. The analog signals, right, took up way more actual bandwidth than if you convert things to digital, and you can do a lot more on disk space and storage and everything else. In order to meet the 24/7/365 quality of service that you need for broadcasting, it's live in many cases. There's no, oops, I dropped that, let's try it again in 5 minutes. If you're doing a live sporting event, you can't miss a frame. If it's a live news event, you can't miss a frame. You can't drop it, you can't reorder it, you can't do anything. So, let's not have the lights on. That's Ronaldo. No, just made it worse. There, one more, okay. Same persons. It's my it's my comic relief in the back of the room. Okay. So anyway, in order to do what we needed to get done with that high level of quality of service, with real time and the amount of bandwidth that was needed, we had to create industry-specific interfaces and transports and protocols. We all get that, right? So back 30 years ago or more, nobody had these things. Right? Personal devices. What we did back then was we took a bunch of SDI cables, we hooked them up. We then did one of 2 things. We either had a pad of paper and we wrote down the connections, and we took a piece of tape and we stuck it on the wall. There's our router switch. And I see many of you laughing because you're probably still doing it. So, or the more advanced people would then go to the PC that was in your office, because we didn't have handhelds, right? And we would type it into a spreadsheet, and then what would we do? We print the spreadsheet, put the spreadsheet on the wall. Either way, it was static connections that changed rarely like that. That's how we did it. The equipment itself was industry specific, which means even though there's a lot, I mean, if you look around the world, there's probably on the orders of tens of thousands of broadcasters, each ordering equipment. So maybe it's couple of million pieces of equipment. It's a good size market, maybe tens of millions pieces of equipment, good size market, but it's not the same as what happened over the past 30 years with information technology. It started that you shared computers with other people, or you only had a terminal, to everybody getting their own personal computer, to everybody getting their smartphones, and now I have 3 devices with me that are all logged onto the web here, just me. 3 devices just for me here. So our lives have changed, IT has changed. The way Ethernet worked, 30 years ago, if you talked about delivering live real-time video over the internet, you would have been laughed at. Can't happen, doesn't work. Even sending it over a LAN, a local area network, couldn't work because Ethernet was collision-based. And something happened. A new technology came by when they did star networks with Ethernet, point-to-point Ethernet. And all of a sudden, all the old ways it worked was now a reliable path. And next thing you know, people are building big clusters of these, and they're moving forward. And now we have all these devices all amongst us, and now you can deliver real-time video over the internet. So here's the problem. We're still professional broadcasters, we're still our own industry. We have our own, industry purpose stuff. In the IT industry now, it's not tens of thousands or maybe hundreds, tens of millions of pieces of equipment. It's billions of people, or tens or hundreds of billions, and perhaps 1 trillion devices or more. So the economies of scale in IT are there, so more innovation happens in the economies of scale, the price point drops. So if you're doing your own studio and you spend all that infrastructure, and somebody else comes in and they can deliver near broadcast quality content or broadcast quality over the top without all this infrastructure, you're at a disadvantage. So how do we leverage off of that? How do we make what we're doing more agile? How do we do something better? How do we stop having 2 separate systems, one for IT and one for broadcasting? Is there a way to do that? So this is a picture here of what your broadcast center will look like in the 2020s. 2020s next year. So in the early 2020s, this is what it's going to look like. What does that look like? Looks like your IT center does today. Now, I'm being a little facetious on this, right? Because there's some interface equipment that's a little different. But this is not that far from the truth on how this stuff will work. So how do we get there from where we are? So why we even want to do this? I've mentioned some. It's really about flexibility and agility. You have to be able to make changes and be able to grow at a reasonable cost point to do that. If you take a look at SDI, as wonderful as it is, the technology itself, except the physical layer, is 30 years old. And we talked about this before, about technology marching forward. In that one cable, no matter what SDI you have, there is one video service, maybe multiple audios and ancillary data like captions and active format description. Hey, now you know an HDR metadata, right? That's in that signal, but there's only one. So it's a one-to-one relationship and it's unidirectional. If you take a look at the IT system, a single connection of similar bandwidth could have thousands of different services on it. And it's bidirectional. So what do we do with that? Because how can we compete with that type of scaling on that? It's inherently denser and bidirectional, and it's agnostic to the video format. So instead of having 30 different SDI standards, you have one professional video over Ethernet standard or IP standard, because it's agnostic, it's a generic package for that. This is where we need to go. We also, because there's multiple streams in there, you now have to be able to identify dynamically what are those streams and their associations of each other, because it's no longer just one. So this is really about getting ourselves to the modern world with all these different changes you have on here. You'd like to leverage and not reinvent. We could do this now and have, SMPTE or the ITU go and reinvent industry-specific interfaces, take advantage of the IT stuff, or why not just leverage it as layers and reuse what the IT industry is doing, with one caveat. It must still support 24/7 by 365, real-time, high-quality service. It's not a regular, internet or Ethernet cable where you have packet retransmission with the same requirements. So we need to make leverage the technology that's there, but make it work for broadcasting. Does that make sense? So if you heard the term information highway all the time, you refer to the internet, right? Well, consider our way as the on-ramp to do that is through these new ways, IP for contribution, production, and playout. So at the simplest form, and it's much bigger than this, but I just want to give you some simple forms of this. This is a example setup that was done for the NAB IP showcase last year. So at the NAB show in Vegas last April, how many people here went to the IP showcase that was there? Anybody? Okay, a couple of people did, all right. So you know it was an interop showing about 50 vendors on there. And one of the things they were trying to do for interoperability with these new standards was show one of the differences. So I stole this from that. They know I stole it, but I still stole it nonetheless. I'm giving them full credit for it. So what we have here is an example of a outside broadcast truck that's been upgraded to do 4K. So this truck has basically either 10 gigabit Ethernet or 40 gigabit Ethernet transceivers throughout it. If it was being built now, you wouldn't see 40 gig, you'd see 25 gigs. And the years were 25 gigs and lanes of 25 gigs have overdone the 40 gig. But this truck was 10 or 40 gigabit Ethernet. And this truck has all the signals necessary in it to support 32 4K Ultra HD cameras, 12 replay servers,